Hello students, today we are going to discuss diffusion and effusion. These are very important topics. So let us discuss what is diffusion firstly. Diffusion. So diffusion can be explained as this statement is diffusion is the process by which molecule of different substance mingle with each other, that is mix with each other. Let us understand what is diffusion. So we have apparatus like this. Here we have filled S2 and let's suppose its pressure is 5 atm, and here we have filled O2 and let's suppose its pressure is 1 atm. O2, and this is blocked. Let's suppose we open this blockage. We open this blockage and let the both gas free to mingle with each other or to mix with each other. So some amount of this gas comes here, some amount of this gas comes here, and they both gas mix out thoroughly in this container. So this process is known as the diffusion process. So this is the diffusion. Now let us understand how it is different from effusion. So effusion is defined as escape of gas from a tiny hole. Now escape of gas from a tiny hole. So you will say that this is also the escape of gas from this hole, the escape of gas from this hole, but no, here escape of a gas from a tiny hole as in a puncture or in an inflated balloon. How it is different? Let's suppose here it is a balloon and we puncture it from here. So the gas filled inside the balloon comes out, but no gas goes into the balloon. In this way, the one-sided motion of gas takes place here, and this type of motion of gas is called the effusion of gas. Now questions are asked in the competitive examination from effusion and diffusion. So Graham explained these both effusion and diffusion. He gives a law, effusion and diffusion. So it is known as Graham's law of effusion and diffusion. Graham's law of effusion and diffusion. Now what is Graham's law of effusion and diffusion? Graham stated that under similar condition of temperature and pressure, the rate of diffusion, that is rate by which gas mixes with each other, and the rate of effusion of gas is inversely proportional to rate is inversely proportional to 1 by under root of molecular masses of gas. So let write this law. Rate of effusion or diffusion is directly proportional to 1 by molecular mass to the power 1 by 2. So suppose a gas have rate R1 is proportional to its molecular mass of 1 by under root of its molecular mass, and the rate of effusion of another gas is R2, which is proportional to 1 by under root of its molecular mass. So if we apply a constant R1 is equal to K under root M1 and R2 is equal to K under root M2. Now dividing both these equations, we have R1 upon R2 is equal to under root of M2 by M1. Now since we know that density is equal to mass by volume, so this implies mass is equal to volume into density. So if here we put volume V, suppose both gases have volume V and their density are D2 and D1. So here also we put volume into D1. If we cut this, so D2 by D1. So rate of effusion of first gas by rate of effusion of second gas is equal to under root of molecular mass of second gas upon molecular mass of first gas is equal to density of second gas upon density of first gas. This is the important rule which helps in solving question in examination. Now suppose how questions are asked in the examination. Given that 20 ml not 20 ml 20 liter of SO2 diffuse through a porous partition in 60 seconds and volume of O2 diffuses under same condition in 30 seconds, will be, it is asked. So 20 liter of SO2 diffuses in 60 seconds and the volume of O2 diffuses in 30 seconds will be under same condition. So rate of diffusion of SO2 will be 20 liter diffuses in 60 seconds. So rate of diffusion will be 1 by 3 liter per second. Now we know that rate of diffusion of SO2 upon rate of diffusion of O2 is equal to molecular mass of O2 upon molecular mass of SO2. So we know that molecular mass of O2 is equal to 32 and molecular mass of SO2 is equal to 64. We will calculate, it must be 64. So it must be 1 by under root 2. Now we have seen that our rate of diffusion of SO2 by rate of diffusion of O2 is equal to under root of 1 by 3, and we have calculated previously that this will be 1 by 3. So this implies rate of diffusion of O2 is equal to root 2 by this must be 1 by 3, this not this 1 by root 2. So if you multiply root 2 here, then it must be root 2 by 3. So rate of diffusion is equal to root 2 by 3. Also, previously we have seen that rate of diffusion of SO2, when we calculated, we see that rate of diffusion is volume by time. So here also it must be equal to volume by time. So volume by time is equal to root 2 by 3. So here time is given 30 seconds. So what will be the volume? Volume by 30 seconds is equal to root 2 by 3. This implies volume is equal to root 2 by 3 into 30 is equal to 14.14 liter. So in this way the questions are asked in the examination through effusion and diffusion. Thank you very much.